All right. Parallel line proofs is what we're going to be doing. So in your packet from yesterday, just pick it up there on the parallel line proof. So that page looks like that. Doing proofs, all the same stuff that we've done in the past kind of still is in the game, but we're adding in those converse theorems that we talked about yesterday, and then other things that we know about. So in this particular proof for number one there, they give us that 4 and 7 are supplementary. So the first line should be that. Angle 4 and angle 7 are supplementary. Because it was given to us. Okay. 4 and 7 are supplementary. What else do we know? Okay, that would be one way of going there. Okay, so if we did 4 and 5 are consecutive interior angles, that could get us somewhere. And then 5 and 7 are vertical, but can vertical angles ever prove lines parallel? No. Okay, so maybe don't go that route. So ooh, now there we go. Corresponding angles can prove lines parallel, right? So if we do 4 and 3 are a linear pair, that would be that 4 and 3 are also what? Yeah. So we'll say that. What does the linear pair definition tell us? It says that angle 4 and angle 3 are supplementary. Supplementary. Because they're a linear pair. Okay, and then 3 and 7 are corresponding. Change colors here. Angle 3 is congruent to angle 7. So wanted to write 4 there instead of 3. The reason 3 would be corresponding angles. Oh, hold up. Back up. We're trying to prove the lines parallel. When are corresponding angles parallel or congruent? Only when the lines are parallel. Are the lines parallel yet? No. So we can't do that. Back up. That was quick. Let's go back. All right. So, seeing vertical angles can't prove it that way. We can't say corresponding angles are congruent because we don't know if the lines are parallel yet. They look it, but we don't have a proof that says they are out of that. So, I think you're on the right track with the linear pair, though. We just need to do a different linear pair. No. Because the only way 3 and 6 can be used there is because it would be, they would have to be supplementary as consecutive interiors. And that only happens if they are parallel already. And we don't know that they're parallel already. Can you say 1 and 7 are nope. The only way that alternate exteriors are congruent is if the lines are parallel already. We're trying to prove the lines are parallel. But 7 and 4 are supplementary, and 1 of them have to be supplementary. But 1 and 7 is the tie together to get the congruent. Okay, so how do we get there with that? Certain theorem that we need that allows us to say then the lines are parallel. 1 and 4 are 4 and 7 are supplementary. We know that because it was given to us If I go down here and pick up 6 and 7, make a linear pair the same way 1 and 4 do, right? Okay, so if I'm going to go that direction, let's do 6 and 7 are a linear pair. So that means 6 and 7 are supplementary. Angle 6, change the red there. Angle 6 and angle 7 are supplementary because of a linear pair. I'm using this angle set. We could have used the one Haley was talking about with 1 and 4 if you wanted to. We do the same thing. And that's because they're a linear pair. So linear pairs are supplementary angles. And then look at the two lines we have. 4 and 7 are supplementary. 6 and 7.
So that means that 4 and 6, yes. 4 and 6 are supplementary.
4 and 6 are supplementary.
Congruent supplement theorem.
Yeah, there you go. Congruent supplements theorem. Good job. Angle 4 and angle 6 are supplementary. All right, so let's say it that way. That's a little shorter writing thing there. Congruent supplements. Theorem. And then now we get that punchline that line J is parallel to line K because 4 and 6 are what? Alternate interior angles converse. If alternate interior angles are congruent to one another, then the lines are parallel. We're using that. If you'd used 1 and 4, you could have done the same thing and then used alternate exterior angles converse out of that. So Haley was doing the 1 and 4. That would work as well as a linear pair. And then the next line would say, well, angle 1 and angle 7 are then congruent to one another through congruent supplements theorem. And then angle alternate exterior angles converse would be the one that would get the punchline there. So different ways to prove that those lines parallel, but they both involve similar attacks. Number 2. Ooh, they give us that the lines are parallel already. That's nice. Line A and B are parallel to one another, and then angle 2 and 3 are congruent to one another. So I'm going to, on line 1, just do A parallel to B, then angle 2 is congruent to angle 3. Just go ahead and get both of the givens in there. We want to prove that angle 1 is congruent to angle 3. Okay. Okay. So angle 1 would be congruent to angle 2 through alternate interior angles. Not supplements because they're not supplementary. But so what would, if 2 is congruent to 3 and or transitive, because there's 3 things there, I would take either of those on that. So 3 would be our punch. We don't need all our lines here. So angle 1 is congruent to angle 3. And I'm going to write transitive property on that. Substitution, I would have taken that as well. So transitive, though, is what I'm using there, since there were 3 things there. So if the lines are parallel, we get all of those angle relationships for free. If the lines are not parallel, we don't get those. So be careful of that. So a big difference in angle, or proof 1 and proof 2 is that. Proof 3, they only give us 3 lines for this one, so it must be pretty easy. It says that angle 1 is congruent to angle 7 is the given. Okay, so 2 would make line L parallel to line M because they are alternate exteriors. Good job. angles converse. And then because they are parallel now, 4 and 8 are corresponding angles. So 4 congruent to angle 8 through corresponding angles. That's nice. Nice and direct. That makes sense to everybody? Well, if it doesn't, ask questions and go from there. So 1 and 7 were congruent to one another, and then we could use a converse to get the lines parallel, which then opens up all of those angle relationships that we have. We can get the lines parallel, all those angle relationships are fair game. If the lines aren't parallel yet, then we can't do that. So that's the key to doing these kind of proofs. 4, another short one. It says angle 5 and 8 are supplementary, so I'm going to do that first. Angle 5 and given. And then, all right, so you're saying that R and S are parallel because those are what? Consecutive exterior angles converse. That's what allows those angles to say that the lines are parallel. So if they're supplementary, consecutive exteriors are supplementary, consecutive interiors are also, but these angles are alternate interior angles. Good job. So kind of following the line of attack here. If you don't have lines parallel and you're trying to prove angles congruent, then the key is to get those lines parallel first. And then that opens up all the angles that you need. Okay. If you're trying to prove lines parallel, then you got to use some angles, little magic with angles to get things to happen there. So let's try 5. They give us that C is parallel to D and that angle 1 and angle 7 are congruent. So I'm going to write those things on line 1. So C parallel to D, angle 1 congruent, angle 7 given. And we're trying to prove that A and B are also parallel out of that. So 1 is congruent to 7. Normally not a relationship between 1 and 7 because they're on different transversals. We go back to yesterday and we talked about the different, if they're on different transversals, there's no relationship between them. So we've got to find a relationship to go with that.
Did you not do Yeah, 1 and 5 are corresponding angles.
Angle 1 and angle 5 are corresponding. Okay. So, but are they congruent to one another?
Yes. Yeah.
No. C and D are parallel, not A and B yet. 5 and 7 could be corresponding. So that would be the idea there. So angle 5 is congruent to angle 7 because those are corresponding angles. Okay.
Did you not substitute from 1 and for 7 because you already know those two are congruent? So angle 1 is congruent.
Okay. Angle 5 is congruent to angle 1 through transitive.
So if 1 and 5 are congruent, then the corresponding angles, so that would make a midpoint.
A parallel D through, what's our reason for that? Corresponding angles converse. Good job. That's not the only route that you could use to get there. You could use angles 1 and 5 or you could use 7 and 6 with consecutive interiors, the 180, and then 5 and 6 are also had to be 180. And if you know that congruent supplements could be the route you take. It's a little longer route, but this way I think was much more direct. Y'all did a good job on that one. Different ways of getting there. All right, good job. Let's do 6. Ooh, they give us parallel lines. Yay. J is parallel to K. I get excited when they give us that because it tells us everything. We get all those angles for free. We don't have to do any work to get angles congruent to one another. And we want to prove that 1 and 7 are supplements. Okay. Okay. And so 1 and 5 make a linear pair, so they're supplementary. You could do that direction. I don't care. Linear pair is a reason for that. Because J and K are already parallel, so those corresponding angles are congruent. So 3 angle 5 is congruent to angle 7. 3 corresponding angles. So that means angle 1 and 7 are supplementary through what? No. Nope. Congruent supplements. You're never going to use substitution unless you're talking about measurements. Okay? And transitive property has to have either equal signs or congruent symbols. We only have one congruent symbol in our proof so far. So to do transitive, we would have to have somewhere else where another set of angles is congruent with one another to use a transitive property. Here we're talking about the word supplement, so that's a congruent supplements theorem. When you're talking about the name. Do what? That's right. Sure. Okay. All right. Line AB is parallel to line CD. Measure of angle ABC is equal to the measure of angle ADC. So. Yeah, alphabet's tough. It's hard. All right, and we want to prove that AD, so we want to prove the two lines that go this way are parallel to one another. So we've got to do some work with angles here.
Oh, I hate angles.
So angle ABC, the measure of it is the same as the measure of angle ADC. But we got the parallel lines to work through here, so. How do we want to go through that? So we know AB is parallel to CD. So we got to pick a transversal. A and C doesn't tell me anything.
A and D would be consecutive base 2.
A and D are not anything. There's more than one angle at that spot. You can't name it by one letter. You have to tell me what angle you're going in direction of. I've got this angle on the outside. I've got an angle that goes on the inside. I got 4 angles at that D spot. Which angle are you talking about? You can't just say angle D, because there's 4 angles at that spot. So I've got to know which one you're talking about. You can't just say angle A, because there's 4 angles at point A. There's 4 angles at point B. There's 4 angles at point C. So when you name an angle, you got to use 3 letters here. Okay, so if we know line AB is parallel to CD, and then keep in mind the other given, we got ABC and ADC. ABC, how can I relate? Maybe I want to use that angle since it's one of the givens, and tell me what angle it is also maybe congruent to or supplementary with. We got all of those things here to use this. So ABC, let's start with that angle. Angle ABC is what? And we remember we want to get over here to get AD is parallel to BC.
Corresponding interior angles with.
There's no such thing as corresponding interior angles.
C word.
There's a lot of C's. Consecutive interior, is that what you're trying to say?
Yeah.
Consecutive interior to what angle? BCD, okay? Which would mean that they are what? So angle ABC and angle BCD are supplementary. Because they're consecutive interior angles. Okay. So what does that mean about them? This is what I'm thinking. I'm going to take what you said in statement 2 and write it as a math problem. What's it mean to be supplementary? It means they had to be 180, right? So the measure of angle ABC plus the measure of angle BCD equals 180 degrees, because that's the definition of supplementary angles. Why am I changing over to measurements? Look at what information we already have. The information we already have has measurements in it, right? So at some point, I'm going to have to bridge the gap between the measurement of the object and getting the objects congruent to one another or supplementary to one another. Okay? If I know that the measure of angle ABC plus the measure of angle BCD, where's BCD? BCD is here. These two are supplementary, so they add up to be 180. What an ADC and ABC are congruent, are equal to each other, right? So what could I do in the statement 3 that I have here that would get me 2 different angles to add to be 180? I could substitute for what? ABC, I could substitute in the measure of angle ADC plus the measure of angle BCD equals 180. So that's this angle, and ADC is this angle. What are those 2 angles now? They're supplementary. So angle ADC and angle BCD are supplementary by definition of supplementary angles. How? Yes. So ADC and BCD are consecutive interior angles, and if consecutive interior angles are supplementary, then the lines are parallel. So our punchline there is AD is parallel to BC through the consecutive interior angles converse. Not the only way to do that proof, but that go in that direction using those would work. If you went another direction, you're going to have to do a very similar process in doing that. Okay. Number 8, they give us 2 line sets that are parallel to that. So that's nice. R parallel to S, S parallel to T, given. Yes. Transitive property allows that to the parallel lines to work with that. And then because R is now parallel to T, we get this all of the angle stuff with lines R and T working. And so we pretend line S is not there, and we try to get angle 6 congruent to angle 7. So 6 and 7 are what kind of angles? Alternate exteriors. So since those lines are parallel, we get that relationship for free. Angle 6 is congruent to angle 7 through alternate exterior angles. Not the converse, but just alternate exterior. Yes, sir. Converse is only used to prove lines parallel, not to prove angles congruent. Converse is only used to prove lines parallel. So if your statement is that this line is parallel to that line, you're probably going to use a converse theorem, or you should be using a converse theorem. All right. 9. Angle 5 and 16 are supplementary. Angle 2 is congruent to 18. Boy, there's a lot of stuff in that picture. We want to prove Q parallel to R. Okay. First thing, angle 5 and angle 16 are supplementary. I'm just going to write one of the givens here. I don't really have room to write the other one. And then I'm going to write the second one on the second line. So angle 2 is congruent to angle 18. You can fit them in there on the first line. That's fine. I wrote too big, so I won't need all those lines there. All right. Now, where do we go from there? P and Q parallel because they're what kind of angles? Consecutive exteriors. So line 3, P is parallel to Q through consecutive exterior angles. And do I use converse on this one or not? Yes. Again, the idea is if you're proving lines parallel, then converse is going to have to be on your theorem there. Okay, so if P is parallel to Q, and we know that 2 is congruent to 18, what do we, okay, how are we going to, we hadn't used that part of the given yet. So I got to figure in the next 2 lines, that's got to somehow be related. Surely they didn't give us information we didn't need. Two and 18 are corresponding, but and they are congruent. So if 2 and 18 are corresponding and are congruent, then what does that tell us about what lines? P and R. Yeah, so line 4 or statement 4 would be that line P is parallel to line R. Through the corresponding angles converse. Good job, good job. So Q is parallel to R through the transitive property. Good job, you guys. You're doing good. The pictures get more complicated. It gets, it's easy to get sidetracked on them, but again, keep in mind all of those simple things here. Simpler picture here on number 10. 1 and 7 are supplementary. We want to prove that line A and B are parallel to one another. So we're going to prove the lines parallel. So angle 1 and angle 7 are supplements. Given. Okay. Okay. So you're saying the next line you're saying is 1 and 2 are a linear pair. So angle 1 and angle 2 are supplementary. They're a linear pair. Not through transitive property. No, not alternate interiors. Congruent supplements theorem. So what's our statement got to be for that? So if angle 1 and angle 7 are supplementary, and angle 1 and angle 2 are supplementary,
John Tyler Milford.
The next statement should say that no, that we can't. Yeah, you could say angle 2 is congruent to angle 7 through congruent supplements theorem. Yeah, you could say that. Congruent supplements theorem. And if they're alternate interior angles are congruent on parallel lines, so that would line 4 would be line A is parallel to line B. So alternate interior angles converse. Definitely a lot of different ways you could go with that. You could do different angle pairs there to get that going on. You could even do what do we know about angles 1 and 6? Just talking about a different route. They're vertical, and what do we know about always about vertical angles? They're congruent to one another. So if 1 is congruent to 6, then and 1 and 7 are supplementary, then 6 and 7 would be supplementary. And if 6 and 7 are supplementary, they're consecutive interiors, right? So you could use the consecutive interior angles converse to prove them parallel. So it's a different route, not any longer, not any shorter, same outcome though. So there's different routes to go to prove these things happening, because you've got all of these different angles going on there that you could use, and all of those different things that we know about. Couple more, 3 more, then I'll let you do some on your own. So we got WT is parallel to XV, and angle XWT is congruent to ZVR. And then we want to prove that XY is parallel to a VZ. That is weird. It seems incorrect there. We're going to do it. Let's do it. All right, so I'm just going to put my WT parallel to XV, and angle XWT congruent to angle ZVR. Okay, and that's given. So all the given stuff is fit on a one line. So WT parallel to XV, that gives us opens up a lot of things as far as angles go. WT and XV being parallel gets us all those angle relationships. So what could we use that would kind of get us in the right direction there? XWT is what would get us down to the next angle there. Could be to WXV, true, but then that enters into the adding to be 180 idea. I could do congruent with these two, right? As they're what? Corresponding, right? So I'm gonna go that route. So angle XWT is congruent to angle YXV with corresponding angles. And if XWT is congruent to ZVR from the given, and then XWT is congruent to YXV, then using this part, angle ZVR has got to be congruent to angle YXV, right? Through the transitive property. So in my picture, ZVR is also congruent, and we're trying to prove XY, which is right here, parallel to VZ, right here. What do we know about these two angles? What kind of angles are those? They're corresponding angles that are congruent to one another, right? So then our punchline is right there. XY parallel to VZ, corresponding angles converse. Not bad, pretty easy. Ooh, we got a bisector. That's new. Hadn't had one of those yet, right? So line JL bisects angle NKH, and then line, segment JL is parallel to segment FI. So I'm gonna put all that stuff in my given there. JL bisects angle NKH, and JL is parallel to FI. All that stuff was given, so a lot of stuff there. So let's try to use some of that. So line JL bisects angle NKH. So that's the angle that they were talking about. And line JL cuts that as a bisector. What does that mean? What does that part of the given do for us in that picture? What's a bisector do? Cuts it into two equal parts. What are the two equal parts in that angle? In NKL, which is also called angle 1 in our picture, and LKH are the two angles. The other side is the obtuse angle there. So we always want to look to the smaller side of the angle there. So angle 1 and 2 should be congruent to each other by definition of an angle bisector. Okay, so statement 2, the angle 1 is congruent to angle 2 by definition of an angle bisector. So anytime they give you something about a bisector, you know you're going to get some equal parts, a couple of equal parts out of that. So there we use that part of the given. I'm going to erase my lines here and maybe make that mark on the 1 and 2, so that maybe helps us. And then JL is parallel to FI. So this line and this line are parallel to one another. So I'm just making marks on my picture so that kind of focuses me on what's going on. I heard a lot of talk. So it was all blended together, so I got nothing out of it. So one at a time. So
She said 2 and 4 were corresponding.
2 and 4 are corresponding and congruent, both of those things, because the transversal, when you're talking about angle 2 and angle 4, what's the transversal? It's that line MK or MH, whichever one you want to call it, or KH. All of those things. So that's useful. Angle 2 is congruent to angle 4 because of corresponding angles. Okay, so you're saying your statement 4 should be that angle 1 is congruent to angle 4. Okay. Does that, how does that help us? They're not supplements. Okay. Through transitive property. Seems to do the job, doesn't it? That's what we were trying to prove, wasn't it? That would work. Gave us a lot of extra lines for that. A lot of different ways to get there. That's a pretty direct way. Good job. Not bad at all. What if we wanted to prove that angle 1 was congruent to angle 3? They're definitely on different transversals. What would be our route? Next. 2 and 3 are congruent by what? Alternate interiors, and then you could do transitive again to do that. What would be another way that would employ using angle 4? You got verticals, and you could use that. So just looking at pictures and trying to figure out different ways to get the different results out of that. If you can see those things happening, you're going to be fine with this stuff. All right, number 13, last one we're going to do together, and then I'm going to let you guys handle the rest of it. Angle or line P is parallel to line Q, and line L is parallel to line M. They give us all of that stuff. That seems too easy then. And they want 2 and 5 to be congruent. But they're not on the same transversals, so. Okay, so angle 2 is congruent to angle 3 by what? Alternate interiors. Three is congruent to 5. Corresponding. And then we could do 2 is congruent to 5 through transitive. Good job. All right, look at 14 and 15. See if y'all can figure those out. Yeah. See if you can do 14 and 15.